Hurtling through interstellar space more than 15 billion miles from Earth, Voyager 1 has once again defied expectations and stunned the scientific community. A mission once thought to be living on borrowed time has suddenly become a source of profound mystery and awe. What began as a simple data stream turned into an extraordinary revelation, an event so unthinkable that it is forcing scientists to reconsider what is possible in the silent darkness beyond our solar system. Launched in 1977, Voyager 1 was originally designed to carry out a grand tour of Jupiter and Saturn. It fulfilled that mission spectacularly, sending back images and discoveries that transformed humanity's understanding of the outer planets. Afterward, its role shifted to an extended mission: drift into interstellar space and send back whatever information it could for as long as its power and instruments allowed. Over time, one by one, its systems were powered down to conserve energy. The world expected Voyager 1's voice to slowly fade, disappearing into the endless void. But instead of silence, the spacecraft delivered something extraordinary. Without warning, Voyager 1 transmitted a structured, complex signal that puzzled NASA's engineers. It wasn't routine telemetry. It wasn't cosmic background noise. The transmission carried distinct patterns and sequences that suggested something deliberate. When the data was decoded, it revealed something that no one thought possible. Voyager 1 had executed a precise reorientation maneuver, realigning its antenna to strengthen communications with Earth. Even more shocking, it had done this without any command from mission control. This maneuver was far from simple. Many of the probe's attitude control thrusters had long been considered nearly unusable. Its gyroscopes had degraded, and power levels were so low that critical subsystems had been shut down years earlier. And yet, somehow, Voyager 1 had assessed its deviation, calculated a correction, and reactivated dormant systems in just the right sequence to succeed. A spacecraft built with 1970s technology, running on outdated hardware and software, had acted with a kind of autonomy no one believed it still possessed. The revelation sparked disbelief at NASA's Jet Propulsion Laboratory. Engineers studied the telemetry over and over, but the conclusion remained the same: Voyager 1 had made the decision on its own. It had monitored its alignment, recognized a problem, and carried out an intricate adjustment maneuver to solve it. This wasn't just a machine performing its programmed tasks. It was something more, something bordering on emergent behavior from a system that should have been far too limited. What came next deepened the mystery. After the reorientation, Voyager 1 began transmitting entirely new readings. Its instruments detected a dramatic change in the conditions of interstellar space. Particle density shifted. Magnetic fields behaved in ways never before recorded. Cosmic rays hitting the spacecraft suddenly changed in spectrum and intensity. It was as if the probe had crossed into a different kind of space altogether. The data pointed toward the existence of a massive layered structure in the depths of interstellar space, a structure no telescope on Earth had ever seen. This was not a star, a planet, or even a dust cloud. It seemed more like a vast sheath of differentiated space, an invisible zone with its own strange physics. Some scientists speculated it might be a gigantic interstellar magnetic bubble, a boundary separating different sectors of the galaxy. Others suggested it could be part of a much larger structure whose true scale and nature remain unknown. Even more astonishing was Voyager 1's response. Instead of continuing to operate as if nothing had changed, the spacecraft seemed to adapt. It altered its data formatting protocols to protect the integrity of its transmissions against interference. It shifted modes on its own, as if it understood that the environment around it had changed and adjusted accordingly. What Voyager 1 has accomplished is not simply a triumph of engineering, it is a revelation. A machine that should be fading into silence has instead acted with unexpected resilience and autonomy, responding to the unknown in ways no one could have foreseen. In doing so, it has uncovered an entirely new frontier of cosmic mystery. Beyond the edge of our solar system, where human imagination once pictured only emptiness, Voyager 1 has found something astonishing. It has not only survived, it has adapted, and in doing so, it may have just opened the door to secrets about the galaxy that humanity has never dared to imagine. The idea that a spacecraft could detect changes in its environment and then autonomously alter its own behavior to preserve its mission is both unsettling and awe-inspiring. Nothing in Voyager 1's original programming from the late 1970s suggested it could do such a thing. Yet something in its systems, a forgotten subroutine, or perhaps a convergence of data pathways shaped over decades of exposure to the cosmos, allowed it to act in ways that seemed almost like a primitive intelligence emerging from outdated hardware. The reaction from the scientific world was immediate and electric. Across institutes, labs, and online forums, theories poured in. Some believed this was the first real sign of emergent machine behavior on a spacecraft in deep space. Others thought it demonstrated how long-duration autonomous systems might evolve complexity over time. A more radical idea suggested Voyager 1 had not acted alone, but in response to an external stimulus, something in interstellar space we don't yet understand. Whatever the truth, one fact was undeniable. Voyager 1 had exceeded every expectation, showing resilience and autonomy beyond its design, while revealing a region of the cosmos we had never known existed. This was not just a technical marvel. It was a cosmological event. Humanity's most distant probe had stumbled upon something alien to our models of physics, and it had responded. The implications for future exploration are immense. Until now, spacecraft were designed under the assumption that their systems would gradually degrade until they went silent. Now, the possibility of extended autonomy, adaptive behavior, and evolving responses must be factored in. The psychological impact was just as powerful. Voyager 1, once thought to be a fading relic drifting silently into oblivion, has once again surprised us. It proved it can still deliver shock, wonder, and inspiration. But what fascinates scientists most is the nature of the event itself. How could a spacecraft with decades-old computing power make such a decision? Could its long exposure to radiation and magnetic fields in deep space have subtly altered its circuits, producing new and unexpected behaviors? Or could this be our first glimpse of entirely new physics, phenomena that only reveal themselves in the cold expanse far from the Sun? Attempts to replicate Voyager's actions in simulations have failed. Researchers have tried to model the probe's hardware and software environment, but the precise behavior cannot be reproduced. The answer may lie in the unique, time-worn state of Voyager itself, a tangle of aging electronics, degraded systems, and decades of cosmic exposure that cannot be duplicated on Earth. It is a puzzle that may remain unsolved. There is also the haunting possibility that Voyager's unprecedented maneuver was not just random adaptation but a response to something active, something in the void that triggered its change. If true, Voyager 1 has become the first human instrument to interact with a cosmic condition entirely beyond our understanding. This may not be life as we imagine it, but it could be an encounter with forces or structures in the universe we never suspected existed. On a deeper level, Voyager 1's survival and strange behavior remind us of something profound. A spacecraft launched before personal computers became common, powered by decaying plutonium and running ancient code, has reawakened in the farthest reaches of space. Its message is not a faint whisper of fading machinery, but a thunderclap of possibility. Exploration is not over. The universe is not only vast, it is stranger than we dared believe. Voyager 1's sudden shift from relic to harbinger marks a turning point. It challenges our assumptions about machine lifespans, autonomy, and the very nature of awareness. It forces us to ask, What does autonomy mean in a machine built only to obey? How much do we really understand about the environments into which we send our probes? And how much more remains hidden, waiting for discovery in the darkness? Even now, Voyager continues to transmit. Every fragment of its signal is being combed through with urgency, every fluctuation analyzed under the new light of possibility. No longer is it just a ghost ship drifting into infinity. It is a probe that acted, reacted, and perhaps perceived in ways we never imagined. It has become more than a symbol. It is a question. One that hangs at the edge of human knowledge, echoing across billions of miles. As its fragile transmissions continue to reach Earth, they carry not only data but also the weight of this impossible event and the promise of all that still lies beyond.